In this video I'm going to solve every question from the UKMT Junior Maths Challenge from 2018. That's one of the main maths challenges in the UK, usually taken by students aged 11 to 13, but often taken by younger students as well. And if you're preparing for that challenge, then take a look at my free course, Get Ready for the Junior Maths Challenge. In that course you can practice all of these questions as well as questions from other papers, and each question has a video hint and a full video solution. So you can have a go at the question, then watch the hint if you're stuck. That gives you really the best chance of getting the answer by yourself. Then you can see if it's right and then watch the video solution if you want to. It's a really great way to prepare for the Junior Maths Challenge. Over at the course's website I've got loads more courses to prepare for maths challenges and for school maths as well, so I really hope you will take a look over there. But if you'd like to watch the solutions here on YouTube instead, I'll get on with them now. I'll put timestamps below so you can jump to the questions you need, or if you'd like to work through the whole paper with me here, then we'll start at question 1 and you can pause the video at the start of each solution. In question 1 we just want to start by adding 222 to 22, so that's nice and easy here. We get 244 and then we can divide that by 2. You can probably do this in your head as well. We just get 122. And so the answer is C. For a super efficient method, you might just notice that you could divide them each by 2 and add them together, so the answer is just 111 plus 11 and get to 122 really quickly like that. So there were 7 people standing before 9 people leave the carriage. At that point, all those 7 people can sit down and there'll be 2 spare seats. So when 28 people get on, 2 of them can take the spare seats, and there'll be a 28 minus 2, which is 26, who will have to stand. You could also actually count the number of people on the train at each point if you find that easier. So you could say initially there were 80 plus 7 or 87 people on the train. When 9 people get off, that means there are then 78, and then 28 people get on, so we can add 28 to this and say there are 106. There'll be 106 people on the train. 106 minus 80 is 26, but I think my first way is slightly faster, but there's a few different ways you can do the ordering of the additions and the subtractions here. If we take a square and draw a diagonal exactly across it, we know this is a right angle, so it would be 90 degrees in total in the corner of the square, and this diagonal splits that exactly into half, right? So there'll be 45 degrees on this side and 45 degrees on this side. We also know that in an equilateral triangle all the angles are equal and they have to add to 180, so you should know that all the angles are 60 degrees each, and the angle we're looking for here is just the sum of a 60 degrees from the equilateral triangle and 45 degrees from half the right angle, and 60 plus 45 is equal to 105, and so the answer is A. In a regular shape all of the sides have the same length. We know the edge of the regular octagon is 10 centimeters, and an octagon has 8 sides. So 10 times 8 is 80 centimeters is the perimeter of the decagon. We know the decagon is 8 times the perimeter of the octagon, so the decagon's perimeter is 8 times 80, which is 640. The decagon has 10 sides, and so each of its edges must be 640 over 10, which is 64 centimeters long, and so the answer is E. So if we start at 6:15, 2 hours later would be 8:15, so that's already 2 hours, which is 120 minutes. And I need to get to 8:48. 48 minus 15 is 33, so there's another 33 minutes to add on here, and so I get a total of 153 minutes, and the answer is A. One thing you notice here that might be helpful is that 4 plus 7 is 11 and 6 plus 5 is 11, and whatever you make x here, it doesn't really matter in terms of making this diagonal and this row add up to the same total. It doesn't actually help us get x plus y here, but that idea we can apply to the square in the top right corner. So let's say I called this one z. You see, I could make the argument with this diagonal and this column here, because it must be the case that 6 plus 7 plus z is the same as x plus y plus z, right? So basically these two must add up to the same thing as these two to make that diagonal and that column have the same total. So it must be here that x plus y is 6 plus 7, so x plus y is equal to 13, and the answer is D. 20 plus 18 is 38, and 20 times 18 I can just think of as 18 times 2 times 10 to get 360. Now 360 minus 38 is 330 minus 8, which is 322. But the answer is not 322 here, right? We want the integers that are greater than 38 and less than 360. So we don't want to include 38 or 360. So you might just worry a bit about whether we have to like plus 1 or minus 1 or something from this answer. And a great way of thinking about these sorts of rules is just to try it in a simpler case if you're not sure what the rule is meant to be. So what would it be if it was just how many are there between 8 and 10? Well, there's only 1, isn't there? Just 9. So the answer would be 1 if it was how many integers greater than 8 and less than 10. Right, but 10 minus 8 gives us 2. So actually this method of just subtracting the lower one from the higher one kind of overcounts by 1. Right? So the answer here is not 322, but 322 minus 1, which is 321, so the answer is B. So Jill scores this goal halfway through the second quarter of the Teachers versus Pupils netball match. So if we think about the whole match in quarters, let's just draw them out roughly, 1, 2, 3, 4 with time going forward here, then halfway through the second quarter would be here, right? So if I actually split all the quarters in 2, we can see that splits the game in 8ths, right? So that means there's 1, 2, 3 quarters before this point where the goal is, and I read the question very carefully. It says what fraction of the whole match remain to be played, so that's 1 minus 3/8, or you could just count 1, 2, 3, 4, 5/8 that are left to be played, and the answer is D. In this question, we're told the cost of restoring the Flying Scotsman was £4 million, which is 500 times the cost of building this steam engine, which is a train, in 1923. So how much did it cost to build? We need to do 4 million divided by 500. Now 4 million is a 4 with 6 zeros after it, and if I divide that by 500, then I can divide top and bottom by 100 here, effectively cross out 2 zeros, and 40 divided by 5 is 8, so we're just going to be left with an 8 here with 3 zeros, so the answer here is C, £8,000. It says adding 4 of these 5 fractions together gives a total of 1. We want to work out which fraction isn't used. Rather than trying all the combinations out and things here, what I'm going to do is just add together all the fractions and see how much bigger than 1 that is. That's going to be a lot faster, especially because we can see that they all have 18 as an easy denominator. We can put them over. So a half is 9/18, a third is 6/18, a sixth is 3/18, a ninth is 2/18, and 1/18 is just 1/18. So if I add all of these together, I get 9 plus 6 plus 3 plus 2 plus 1, that's 21. So that's 3/18 more than 1, because 1 would be 18/18, and so it must be 3/18 that's not included, and 3/18 corresponded to 1/6, so the answer is C, 1/6. So it's not as hard as it looks here just to do this division, and so this is a reasonable approach here. If I just do 120, 123 into 123, 123, 123, I can't, it doesn't go into 1 or 12, so the first time it works is when it goes into 123, so I get a 1 here, and then I'm going to get 0, 0, 1, 0, 0, 1, 0, 0, 1. So we can pretty quickly do this and just see that the answer is 3, 4, 5, 6, 7, 8, 9, 10, and so the answer is D, 10 here. And you might be able to spot that without doing this calculation as well, especially if you've done problems where you multiply something by 1001 before. I mean, that comes up a lot in Maths Challenge questions, because if I do 1001 times a number like 347, right, that's the same as 1000 times 347 plus 1 times 347. Okay, so that's 347,000 plus 347. So the fact we multiplied by 1000 here, means the 347 just slots nicely on top of the zeros and gives us these sorts of repeating patterns. So where you get a product over that's got repeating patterns in like that may well have a factor that's either 1001 or perhaps 101 or 10,001 or something, depending how long the repeating pattern is here. But as I say, fast to do the division here, so why not or super fast if you can just spot something like saying, you could also just say like what size is this roughly. So when I do this divided by 123, you could say, oh well, I know I'm just going to get like a 1 here and then some other digits, and you don't even have to work out the rest of the calculation. So you could just say, you know, it's going to be as long as this number or something if you're really confident. So neither of those methods takes too long here. So whatever you do, just make sure we get the answer D. Okay, there's a lot of information to take in this question. It tells us that PR bisects SPQ, that's this angle here, so that means that these two are the same. And it also tells us that a ratio of SPR, this one, to PRS, this one, is 2 to 3. And that's the key piece of information we're going to use first here. So the angles in a triangle add up to 180 degrees. So these two, let me just call them x and y for now, x plus y must have to add up to 180 minus 110, which is 70 degrees. So we've got to split that 70 degrees in the ratio of 2 to 3. So there are 5 parts in total in this ratio, 2 plus 3 is 5, and 70 degrees in total. So each part must be 70 divided by 5, which is the same as 140 over 10, or 14. So 2 parts is 2 times 14 is 28, and 3 parts is 3 times 14, which is 42. So that means that these two angles here are actually 28 and 42. Now because we said earlier that this one SPQ bisects the angle, sorry, the PR bisects the angle SPQ, that means that these two are equal, so this one is also 28. And we're also told that this is an isosceles triangle. We've got these two lengths being the same. PQR is isosceles, so that means this angle is also 28, and that means that the angle we're looking for, PQR down here, PQR is going to be 180 minus 28 minus 28, or just 180 minus 56 if you like, which is 124, and so the answer is A, 124 degrees. Each individual face of the cube here is just a 3 by 3 square, so has an area of 9 centimeters squared. So what this question is really about is working out the surface area of this whole shape, and what we really just need to do is count how many faces are actually visible on the outside of the shape here, and if any are covered up. And what you can see here is that it says it's only made from 4 cubes, so all of the 4 we can see here. Now that actually means that every face of all of the cubes are visible. It looks a little bit like from the picture when you first look at it, that those sort of 3 at the back are somehow joined together like with faces attached, but they're not, because there isn't a cube at the back there. We can see all the cubes that are there, so every face is open, and all of the connections between these cubes are just sort of along the edges here, but there are no faces stuck together. So every cube has 6 faces. There are 4 cubes, so we've got 6 times 4 is 24 faces. All of those faces have 9 centimeters squared, so I just need to do 24 times 9. 2 ways of doing this. A lot of people would do 24 times 10 to get 240, and then subtract 24 to get 24 times 9. So that would give me 216. Or you could do something like 20 times 9 is 180. 4 times 9 is 36, and add them together to get 216 as well, or just do an ordinary multiplication if you prefer, whatever method you have. But we are looking for fast multiplication methods, save us a bit of time if we can here. Anyway, either way the answer is D, 216. If Billy has 3 times as many llamas as lambs, his llama to lamb ratio must be 3 to 1. In particular, that means that the total number of animals that he has must be a multiple of 4, because for every 3 times as many llamas as lambs, so for every lamb there's 3 llamas. Millie has twice as many lambs as llamas, so hers are in the ratio of 2 to 1, so for her it must be a multiple of 3, okay, because she's got twice as many lambs as llamas, so for every llama she's got 2 lambs, so they sort of come in little groups of 3. Now, so what we're looking for is a multiple of 4 plus a multiple of 3 that makes 17, and actually there's only one way of doing that. 16 plus, so if I take 16 as the multiple of 4, I've only got 1 left over to make 17. 12 plus 5 9 plus, sorry, that would be 8 plus 9, or 4 plus 13. So you see these are the multiples of 4 and what you need to add to them to make 17. And the only way you can do that with a multiple of 3 is this one, 9, so it must be 8 and 9. So it must be actually that Billy's got 6 to 2 and Millie has 9, so that's going to be 6 to 3. Now I've just got to be really careful which way around they are. So Billy has 3 times as many llamas as lambs, so he's got more llamas, so the llamas are the 6, whereas Millie's got twice as many lambs as llamas, so for her the llamas are the smaller group, so the total number of llamas here is 6 plus 3, and the answer is 9, which is E. So here we're trying to place these L-shaped squares on this 4x4 square. The first thing we notice here is that the 4x4 square has 16 tiles and the L shape has 3. So I'm never going to be able to get 6 on here, right? Because 3 times 6 is 18. I would need 2 more squares if I wasn't going to have any overlapping. So now I'm just going to play around with them and see if I can make it work. If I can find a way of doing 5, we'll be done. Otherwise I'll have to make a more complicated argument. So I try putting them in. So let's say I put an L over like that. Maybe I put one like this. Put one here. I could try putting one here. Now this method hasn't quite worked, so I can maybe try and tweak it. And I'm just going to keep playing around with different ways until I find the way of doing it right. So actually, I think if I want to be efficient, I want to sort of try and not block off squares, so I might try putting an L around here and then one here. Now I've used up the whole of the bottom half, you see. Now I can put one here, that's not without leaving any gaps, and then I can put another one in here somehow, right? So I'm only leaving one spare space here, and that's the best I can do. I found a way of covering it with 5 shapes. So if I played around with that sort of problem a bit longer and I couldn't find a way of doing it, I might start trying to show that it wasn't possible. But the first thing we're going to try and do here is to put as many as we can in. Anyway, the answer there, as you can see, is D5. So we have to remember here that something is a multiple of 15 if and only if it's a multiple of 3 and a multiple of 5, okay? And we've got nice easy tests for when something's a multiple of 5. For it to be a multiple of 5, it has to end in either 0 or 5, and to be a multiple of 3, the digits have to sum to a multiple of 3. Okay, so we're going to put those two things together to work out this question. So it's got to be something 869 something. So to end in a 0 or 5, there's only 2 cases. So it could be either P8690 or P8695. This would guarantee it's a multiple of 5. So I just have to, if I choose P so that these have a digit sum that's a multiple of 3, it'll also be a multiple of 3, and so it'll be a multiple of 15. Now at the moment, the digit sum here without a P is 8 plus 6 plus 9 plus 0. So that's 23. So the first multiple of 3 would be 24. So I could make P equal 1 and have 18690. And then I could add 3, and I'd still have a multiple of 3 obviously. So that would be 48690. Add 3 again to get 78690. And that's all good. There will be all the possibilities for a multiple of 15 there. If I make the last digit 5 instead, so P8695, then 8 plus 6 plus 9 plus 5, that's 28. So the first one bigger than that, that's a multiple of 3, is 30. So that would have to make P2 to take the total up to 30. So I'd have 28695. And then again I could add 3 to the 2 to keep it a multiple of 3, to keep the digit sum a multiple of 3. So we could have 2, 5 or 8 as the first digit there, and I get 3 more options, and so I've found 6 numbers here that are a multiple of 15, and that's all that there can be. This problem isn't too bad if you're not afraid of fractions, so we start by looking at the rectangle here, the 13 centimeter square one, and we know one of its dimensions is 4 centimeters, so it must be 4 times the other dimension, let's call it x, is equal to 13, so x must be 13 over 4. We'll just leave it as a fraction 13 over 4 for now. So now if I look at the other rectangle here, the 25 centimeter squared rectangle, I know that the length here is going to be 3 plus 13 over 4. So we could write 3 as 12 over 4 and add it to 13 over 4, and so that we'd get that the overall length here then of this side is 25 over 4. And then, I probably shouldn't have called this one x because the final answer was x, but that's fine. So the real x in the question now, if I do 25 over 4 times x, then I have to get 25. So you can either do 25 divided by 25 over 4, or you might just spot here, well, okay, look, if I multiply it by 4, that's going to, if I put x equals 4 here, that just cancels out and I get 25. Or alternatively, you could do 25 divided by 25 over 4, which is 25 times 4 over 25, timesing the second one upside down and multiplying, and then the 25s cancel out and we get 4. So the answer here is B4. It's a tricky little problem, and we've got to use all of the numbers, all of the digits between 0 and 9 to make two 5-digit numbers with the difference between as small as possible. The one thing you realise pretty quickly when you start playing around with this is that the first digit of these two numbers must just be 1 apart, right? So it might be like 2 and then 4 digits and 3 and then 4 digits. Or it might be 5 and 6 here or something, but they can only be 1 apart because I'm going to do better if like one answer is in the 20,000s and one is in the 30,000s than if I do one in the 20,000s and one in the 40,000s. So that's the first thing we notice, right? So I'm going to just actually, rather than say 2 and 3 here, let's just say the first digits are A and B. So that's the beginning of the number. Now I want one of the numbers to be the smallest it can be above the thousands, and the other one to be as big as it can be below the thousands, right? So the way to do that would be to make in the first number, would use 0, 1, 2, 3. That's the smallest 4 digits. I can make it go over the thousands, and then in the other one, like the closest it can be just underneath is 9, 8, 7, 6. And now what have I got left? I've got the 4 and the 5 left, so actually these two at the front must have been 5 and 4, and now we can see, okay, so the number I've got at the top here is 50,000 plus 123, and the one on the bottom is 50,000 minus 124, so the difference between them is going to be 123 plus 124, which is 247, and so the answer here is B. So again, some people find these questions relatively easy, some people find them impossible. Because in these you have to sort of visualize what happens when you would fold together these nets, whether you could make a cube or not. The main thing you have to realize here is that these are unusual nets of cubes. Usually they're all made of squares, so we need to put the triangles together in a way to make a square. So once it's folded together, the diagonal faces of the triangles have to be next to each other. And it can't be the case that when you fold them, you get something where they overlap like this, or perhaps, and it's got to be the diagonal faces that come into contact to make a full square. So you have to just think through each one. I mean, if you really want to get better at these, a great thing to do would be to print out a big version of this and actually try to make them, and that'll help you be able to visualize these things better. There's a useful diagram in the solutions I've got here, which says that ways that, and you can sort of see from this, that the ways the diagonal sides could come together would be if they're in a configuration like in this first one on the left here, P, right? If you had just the net with just those pieces, you could just make a fold along here and then push the triangles in, and then those two faces would come together. And similarly, you can see in Q, if you fold it round, along these edges, then these sides become like this, and then you fold the triangles down, and again you can see that from that configuration they would also come together to form a square on the top there. So either of those two can be sensible, and based on that we see that C would work. And if you think about that one, fold it all around, then you see those two would be like in P here, and those two would be like in Q, and they will fold nicely together to give the other sides of the cubes. And you can go through and check all of the other ones, and you'll see that they don't work. But for the maths challenge, it's enough, of course, to just realise that C does work and then go for it. But sometimes, don't be overconfident. Sometimes people look at this and they think, oh, A, they look at A or B or something and they convince themselves that works. If you check the others and if you convince yourself that one of those works as well, you have to go back and rethink it. Anyway, in this example, the answer is definitely C. So we can be confident in that and move on to the next question. Well done if you got it. So we've got 10 yellow socks, 8 blue socks and 4 pink socks that are all identical apart from their colours, and Amrita's going to pick a sock without looking, and it says what's the smallest number she can pick to make sure she has at least 2 pairs of matching socks. So we're looking for the smallest number to make sure she has 2 pairs that match. So we're going to try and think about what the worst case scenario is, and that will then be the smallest number that she must pick, right? So it's not obviously she could be lucky and get it in 4 socks, but that's not what the question's asking. It's saying, what's the worst case scenario effectively to make sure she gets 2 pairs. So clearly, we could pick a yellow, we might end up picking a blue, we might pick a pink, and we wouldn't have made any pairs at this point. But whatever we do next, we must make a pair, right? If I pick a yellow, I'll make a yellow pair, a blue, I'd make a blue pair, or a pink, I'd make a pink pair. So we've got 1 pair at this point. Now, whichever we've picked here, it could be that we don't make a pair on the next one, because actually, let's say I made a yellow pair, I might end up making just another yellow single sock. But then at that point, okay, I've got this pair, and whichever colour I take next is going to make another pair, either yellow, blue or pink. So once I've done that, I'll have 2 pairs for sure. So if we take 6 socks like we've done here, we're guaranteed to get at least 2 pairs, and the answer is B, 6. Hopefully you know that the vowels are A, E, I, O and U, and if we just count the ones that are already in the sentence here, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We see we've got 12 vowels already in this sentence. Now that doesn't mean that the answer is 12 here, because if I put the 12 in this sentence, then actually I'd get 2 more, and so there'd be 14. Right, but we don't have to keep recounting the original sentence, right? So 12 has 2 vowels in it, 13 has 1, 2, 3, 14 has 1, 2, 3, 4, 15 has 3, and 16 has 3. So in each case I'll have 12 plus this number in total once I've included this word. So here I'd have 14, 15, 16, 15, or 15, and that means that the answer is D, 15. If I put that word in here, I get 3 extra vowels, that brings me up to 15, and then the sentence would be true. Another tough question here, when you've got these questions that are about geometric shapes, here about triangles, the best thing to do is to try to draw them out. Right, so let me just put a couple of triangles on the page here. I don't know anything about the shape of them, so I'll just make any old triangle here, and we'll label them P, Q, R and S, T, U. So often once you've got a diagram, the question becomes a lot easier, and it gives us a way of writing down this information. So it says RPQ is 2 times UST. So RPQ is this one here, and UST is this one here, and it's saying RPQ is double UST, so let me call UST X, and in that case RPQ here would be 2X, right? Similarly, it says PRQ is 2 times SUT, so PRQ is PRQ, that's here, and SUT is here. Again, PRQ is double UST, so let's give it a different name, let's call that one Y, and then this one would be 2Y. Right? And the last one, it says RQP is a fifth of UTS, so RQP here is a fifth of UTS, so I could call them Z and 1/5 Z, but I think I'd rather not have fractions, so if this one is a fifth of this one, I could call this one Z and this one 5Z. Now I know that angles in a triangle add up to 180 degrees, so looking at the first triangle, PQR, we would have 2x plus 2y plus z is equal to 180 degrees, and in the second triangle we'd have x plus y plus 5z is equal to 180 degrees. Now to make these match up, what I'm going to do is actually count all the angles in the second triangle twice. Effectively I'm going to double everything in this second equation. So it must be also that 2 lots of x plus 2 lots of y plus 10 lots of z is equal to 360, right? So I'm saying if I had 2 copies of this second triangle, then I would, these would be the total of the angles, and they'd now add up to 360 degrees, right? Because if I compare these two equations now, you can see they've both got 2x and 2y in them. Now in this one I add z, and in this one I add 10z. So the only difference here is that there's more z in the second equation, right? So the extra 9z here must account for the difference between the 180 and the 360. So that gives us that 9z is 180. If you've done simultaneous equations, you can think of this as subtracting equation A from equation B here, but we can also just do it a bit more informally like I've done it there. So if 9z is 180, that means that z is 180 over 9, which is 20. And now which angle do we want? UTS, that's 5z. So 5z is 5 times 20, which is 100. And so the answer is B, 100 degrees. Right, so let's just focus on these ones here. So let me call that one x and that number y. It says everything after the fourth from the left, so everything from the 1 onwards is the sum of the 4 to its left, right? So if I look at the 8 first, that must be the sum of these 4, right? So 8 here is x plus y plus 1 plus 0. Okay, so the x plus y here must just be 7, right? X and y, whatever they are, have to add together to give 7. Now if I think about what's in the final square, well, the final square is going to have these 4 numbers, so the answer to the question here is going to be x plus y plus 1 plus 8, or x plus y plus 9. So without knowing what x and y are individually here, because I know their total is 7, I can just say this is 7 plus 9, which is 16, and so the number in the final square here must be 16, and then the answer is A. So putting in algebra often helps, and I'm going to start here by just calling the side lengths of the rectangles x and y, and all of the rectangles are identical, right? So that means this length is y here, this one is x, this one is y, this one is x, and the only difficult side on shape P is this one, but you can see here that the length that we've got left here is just the y here minus this length here, which would be x. So actually this bit here is y minus x, right? And I can do the same on the other shape. I can just label them. This one will be x, this would be y, this would be y, x, y, x, y, x. And again, for exactly the same reason as in the first one here, we've got this minus this, right? That's y minus x would give you this side, and the same for this side here would have this minus this. That would also be y minus x, right? So now I can just look at each shape. So let's take P, we'll start at the top here and go round. So I'd have x plus y minus x plus x plus y plus x plus y. That would be its perimeter, and we're told in the question that that's 58 centimeters. So here I've got one lot of x that cancels out there, and then 2 more x's, and then I've got 1, 2, 3, 4 y's. So I get 2x plus 4y equals 58. And in the second one here, Q, let's start at the top and go around again. So I've got x plus y minus x plus y minus x plus x plus y plus x plus y plus x plus y, and that's all going to add together to give 85. So if I count these up again, I've got an x that cancels out, another one that cancels out, and then I've got 2 more x's, so that's 2x. Then I've got 1, 2, 3, 4, 5, 6 y's, so 2x plus 6y gives 85. So I've got these simultaneous equations, 2x plus 4y equals 58, and I've got 2x plus 6y equals 85. Now if you've done simultaneous equations as a topic, you might now know you've got to subtract the first one from the second one, or we can also just think of it as looking at these equations, because the maths challenge, they usually give you ones that are quite easy to match up nicely. So here you see you've got 2x plus 4y is 58, and 2x plus 6y is like 2x plus 4y plus another 2y is 85. So this extra 2y must account for the difference between 85 and 58. Right, so either way, whether you do it formally by subtracting one equation from the other or just by thinking it through like that, you see that 2y has to be 85 minus 58, which is here 27. So y is 13.5, but you actually don't need to divide by 2 here and make things messy, because like I could just go back to this equation now and say, well, if 2y is 27, I mean 4y is 54, so this gives me running out of space here, 2x plus 54 is 58, so 2x is equal to 4, right? Because what we're asked for here is what's the perimeter of one of the rectangles, right? And let's make a bit of space here. So the perimeter of one of the rectangles, right, would just be, right, if it's x, y, x, y, it would just be 2x plus 2y, right? So I don't have to even work out the sides individually. I know I've got to do 4 plus 54, so 4 plus 50, sorry, not plus 54, 4 plus 27, because that was 2y is 27, so 4 plus 27 gives me 31 centimeters, and that would be the perimeter. Okay, you could also work out, of course, that y is 13.5 here and x is 2, and then work out 2x plus 2y from there, and you'll get the same. Either way, answer is B, 31 centimeters. In the solution that follows, I say something that is slightly wrong actually, but turns out not to matter, and I want to point this out because it's really interesting here. So in the solution I'm about to give, I say at one point that STR and STP, these triangles, are congruent, right? That they are actually absolutely identical. But I don't really know that, right? In fact, S could be anywhere, right? So as long as I make TS the same length as TR and TP, I mean, S could, could be out here or something, right? So really you should do this question algebraically by saying like, oh, let these two be A and let these two be B, and then do everything in terms of algebra. Now, so I effectively in my solution just say, well, why don't we take A equal to B? And we don't know that that's true. Interestingly, for a maths challenge question, it's actually a fine argument here, because if this question is going to have an answer regardless of where you put S, then it must also have the same answer here, the number of sides, for my nice choice of S here that makes these two angles A the same. So this is quite a subtle piece of advice for these challenges, but sometimes if there is a totally free choice of something, like S can be anywhere here, then if it's true for all the possible places you could put S, it must also be true for the nice version. So the way I've worked it out here with the nice version will be fine. For those of you that want to see it, I'm going to put a second solution to this problem afterwards, where I do it totally in terms of the algebraic way as well, just to convince you. Right, the last question is always a tough one, and I've made a big copy of the diagram here to try and make this it's a little bit easier. The bigger the diagram, the more easily I can write on it. Now, mostly in these geometry questions where we've got a picture here, the words here really just represent this picture, right? So it says the diagram PQ and Q are sides of a regular n-sided polygon. That's these two sides here. We want to find out how many sides the regular polygon has, and the way we tend to do that is to try and work out what the exterior or the interior angle are and use the formula, right? So in particular I tend to use the exterior angle is 360 over n, and so I can see I've got an exterior angle over here, but then I'd have to worry about what these angles are. So the one I'm probably going to want to go for is the exterior angle that's in here, and I'd want to work that out then by, I could know this interior angle, right? So I've got at least a target for this problem. And we know SPQ and SRQ are 80 degrees, so that's the whole of this angle all the way from out here. This angle in the middle is 70, and all the lines are equal that have the lines through them, PT, ST, and RT, so we've got some isosceles triangles. So if we put all of this together, then we'll be able to work it out. Now it's just finding a starting point here. So we know in this isosceles triangle, like those two angles are going to be equal, and that these two angles are going to be equal. We've also got the 70 degrees in the middle, and we can sort of see we've got a perfectly symmetric picture here, so actually these two angles are also going to be equal, and that's where we can start. So the angles of a circle add up to 360 degrees, so to get those, I'm just going to undo all my x, y's and z's so I can write over them. So 360 minus 70, that gives us 290, that's this circle in the middle. So between those two angles, they're going to take up this 290. 290 divided by 2 is 145. So I've got that this is 145 and this is 145. So now in this triangle here, these two angles x have to add up to 180 minus 45, because angles in a triangle add up to 180. So that's 35. 35. So 35 over 2 is 17 and a half, and that means these angles are going to be 17 and a half. So actually this part of the angle here is 80 minus 17.5, just the bit in here. So that's going to give us 62.5. Right. And by the symmetry here, exactly the same down here. Of course, this is 17.5, this is 17.5, and this is 62.5. So now this is a quadrilateral, okay? So that's going to add up, all the angles there are going to add up to 360. So we've got 62.5 plus 62.5 plus 70 plus, let's call it A, the one I'm looking for here. That's going to be 360. So I've got 135 plus 70, that's 205 plus A is 360. So A is 360 minus 205, that's 155. And then the exterior and the interior angles lie on a straight line. So B here, the exterior angle that we're looking for, is 180 minus 155, which is 15. And then finally we can go back to this exterior angle formula and say that the number of sides, okay, we could also write, you can rearrange this, right, and write that the number of sides is 360 degrees divided by the exterior angle. So n is 360 over 15. Factor of 3 top and bottom gives me 120 over 5, and then dividing by 5 here gives me 24. And so the answer must be that the number of sides here is D, 24. Really well done if you got that right. If you weren't convinced by my choice of S making the two triangles equal, we could proceed without knowing they're equal, right? So I could call these two X and these two Y, but it would make all of the algebra, it's just going to make this question a bit harder, but that's fine. That means that this angle in the middle here is 180 minus 2x, because angles in a triangle add up to 180, and in here it's going to be 180 minus 2y, and then because the circle in the middle adds up to 360, so I know 180 minus 2x plus 180 minus 2y plus 70 has to be 360. So the subtracting 360 from both sides just gives me that 2x plus 2y has to be equal to 70 here. So that means that x plus y has to be 35, dividing that by 2. And then the angles in the quadrilateral, right, would be, so I've got to this one's 80 minus x and this one's 80 minus y. So I've got that 70 plus 80 minus x plus 80 minus y plus, let's call this one a again, plus a is equal to 360. Now I add all this together, I get 150 plus 70 is 220, and then I'm going to take off an x and a y, so that's like minus x plus y plus a is 360. So without knowing what the x and the y are individually, I know the total is 35, so that's 220 minus 35 plus a is 360. So that gives me a is 360 minus 220 is 140. Oh, sorry, I've added these together wrong. 80 plus 70 is 230. So 230 minus 35 is 360 minus 230 is 130, and then plus 35 gives us 165 just as before, so then the exterior angle is 180 minus 165, which is 15, and again the number of sides then is 360 over 15, which is 24. But think carefully about that thing I said in the introduction, because it can make these sorts of questions a lot easier, and it was a perfectly valid method of solving the problem in this case. So there we go.